In the diagram, if the area of the rectangle is 2003, what is the area of the rhombus? Well, let me draw it a little bit bigger. That way I can illustrate this a little bit better, I think. Okay, so here we go. This is approximately what the diagram looks like. So now let's talk about this. I'm going to label some lengths here. So from top to bottom, like that, I'll break it up. And this length I will call B, and then therefore this length is B also. Those two, top to bottom. They should be equal. I'm sorry. Maybe if I did it here, it would look equal. Where this is B and that's B. And then from here to here, that whole thing I'll just call A. Like that. Okay. So the rectangle, the area is A times B, and they've already told me that's 2003. Okay, so that's pretty decent. Now what about the rhombus? The rhombus, that is this guy. How do you figure out the area of a rhombus? Well, one way is by multiplying the diagonals. So the first diagonal times the second diagonal divided by 2. So the first diagonal, I guess, would be top to bottom. So that's 2b. And the other diagonal is this all the way across, which is equivalent to a, according to my labeling. So that basically becomes AB, and AB is 2003. So that is the answer. The values of x which satisfy both absolute value of x minus 8 is less than 6 and absolute value of x minus 3 is greater than 5 are precisely the values of x that satisfy a less than x less than b. What is a plus b? Let's start with the first one. X minus 8 absolute value is less than 6. So, interesting. How do I approach this? I think I'm just going to do it in the simplest way. Let me just drop the absolute values, and then we'll take it from there. If it doesn't work out, we can always try the other type, which is, when you multiply by -1. So this basically means that x is less than 14. Okay, so far so good. Let's concentrate on x minus 3 greater than 5. And same thing, just drop the absolute values and see what happens for now. That means x would be greater than 8. Okay, so if you combine these two, it becomes x less than 14 and x is greater than 8. Correct? So that, if we put that side by side with what they've given me, that means that this a is 8 and this b is 14. So that means the a plus b would be 8 plus 14, and that is 22. If the perimeter of a certain right triangle is a positive integer and the difference between the lengths of the hypotenuse and the longer leg is the same as the difference between the lengths of the two legs, what is the least possible perimeter of the triangle? Let's draw a triangle. And it's a right triangle. Okay, that's good. So, and then I'll label it x, y, and z for now. Now let's look at what they're saying. The perimeter of a certain right triangle is a positive integer. All right, so x plus y plus z is some positive integer, and we'll just call that p. The difference between the lengths of the hypotenuse and the longer leg. Okay, so let me just look at that. The difference between the lengths of the hypotenuse and the longer leg. Well, we don't know which is the longer leg here, so let me just say x is greater than y. That means x is the longer leg. So their difference is going to be z minus x, z minus x. Is the same, so equals, that's why I put in the equal sign, the difference between the lengths of the two legs. So that would basically be x minus y. Okay, so that is the setup of the question. And then now I guess we have to answer this. What is the least possible perimeter of the triangle? The least possible perimeter of the triangle. So we're trying to minimize that. Minimize. Okay, let's go for it here. I'm not entirely sure which way to. I guess what we have to do is just concentrate on this. So we have to get x, y, and z all in terms of one variable and then play around with that final result. Okay, so we can do that. Z is equal to, with this equation, 2x minus y. And, where do we go from here? I think that's all we have. Yeah. Okay. So I guess we'd have to concentrate on the fact that it's a right triangle, so that means x squared plus y squared is equal to z squared. Correct? And therefore, this would be x squared plus y squared. Z is this, so we could plug that in there as 2x minus y squared. And then if I expand this, it'll be x squared plus y squared is equal to, what's that, 4x squared minus 4xy plus y squared. And therefore, this is going to be 4xy is equal to 3xy. Oh, sorry, not 3xy, 3x squared, I should say. Get rid of the x's, and that'll just be 4y is equal to 3x. And therefore, y is equal to 3x over 4. Okay, that's some pretty good progress here, because now I can plug that there. And if I do, I'll get z is equal to 2x minus 3x minus 4. And then that would mean z is equal to a 5x over 4. Okay, that's great. That's exactly what I was hoping for. So now I can plug those values into there. So let's do that. So that x plus y plus z is equal to p. That, let's see here, x we'll just keep for now. Y, I'll put that guy in, so that'll be 3x plus 4. And then z, put this one, 5x plus 4. So that's really good, because now I have everything in one variable. Okay, so if I add this, let me just see if I did this correctly first. I think I did. Okay, so this becomes 12x over 4 as p. So that means p is equal to 3x. Okay. So now I guess I just have to fiddle around with values here. So what do I put for, let me see, does this, the perimeter of a certain triangle is a positive integer. Okay. I got it. So this p is a positive integer, and they want you to see what is the least possible. Okay, I got it. Well, the least possible positive integer is 1. Correct? So let me just see if 1 could be possible. If p is 1, this will be 3x. So that means x is 1 over 3. If x is 1 over 3, that means y would be, y is equal to 3/4 times 1, 3. So y would be a quarter. And then z would be 5 over 4 times 1 over 3, which is 5 over 12. Okay? Yeah. With this for x, that for y, and that for z, p would be equal to 1. And I guess that's the conclusion of the question. I flip a fair coin 4 times. What is the probability that I get more heads than tails? Okay, so we got to flip it 4 times. So 1, 2, 3, 4. And then let me write down how many scenarios there are. Okay, you can have all 4 heads. So 4 heads, right? So we got H, 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 H. And there's only one way. Number of ways. There's only one way of doing that. Then you have a 3H and 1T scenario. 3 heads and 1 tails. So you're going to have this, where the tail is last, or where the tail is the third flip, or the tail is the second flip, or the tail is the first flip. And as you can see, that is 4 ways of doing that. 4 ways of that scenario. And then you have the scenario where you have 2 H's and 2 T's, and there is 6 ways of doing that. H, H, T, T, and I'll just let you figure out the iterations, like for example, H, T, that kind of stuff. And then the other one is h, 1h and 3 t's, and that's 4. Very similar to this one here, where you have 1h and 3 t's. And then finally you have the 4t scenario, and that's just, of course, all t's, and there's only one way. So the total number of ways, it looks like 1 plus 4, which is 5, 16. So there's 16 ways of having an outcome. But they want that you have more heads than tails. More heads than tails. So which one of those are in that category? This one is, these ones are, but this is not. That's the same number of heads and tails, and this is less heads than tails, and there's no heads there. So it's just this and this that satisfy the criteria of the question. That's 5. So the probability would be those 5 out of the total, which is 16. So 5 out of the 16. What is the x-coordinate of the point on the x-axis which is equidistant from 8, 5 and negative 2, 3? Okay, let's draw a little diagram and let's see what we have. So x-axis, y-axis. So let's first put in the 8, 5. So 8, 5 is approximately here. 8, 5. And what's the other guy? Minus 2, 3. So somewhere here approximately. Minus 2, 3. Okay, so they're saying that there's a point on the x-axis. Okay, that's helps us. So I don't know where it is. So let's say it's somewhere here. And it's equidistant from the 2 points. So if you drew a line from there to there and from there to there, those two would be equal. And since this point is on the x-axis, it would be of the form x0. All right. So what do I do now? Okay, well, we can create two triangles like that, and these are right triangles. So that means the hypotenuses would be equal. So that means using Pythagoras, this squared plus this squared would be the same as that squared plus that squared, because they both equal the hypotenuse. So that's, this side is 3, right? So 3 squared plus, it would be x plus 2 squared. And then on that side, it would be 8 minus x squared, and then 5. Right. Okay, let's expand this out. 9 plus x squared plus 4x plus 4. And that is, hold on. I think that should have been an x. Sorry about that. It's a good thing I caught that. 64 minus 16x plus x squared plus 25. The x's cancel. Let's see what else cancels here. This becomes 20x. We have 89 minus 13, I think. Yeah. So 20x is equal to 76. So x would be 76 over 20, which is 3.8, I believe. Yeah, 3.8. Five points, not necessarily different, are selected on a number line so that the distance between any two of these points is at most 1. After I calculate the distance between each pair of points, I add all 10 distances. What is the greatest possible value of the sum? Let's make a little number line, and let's see what we get here. Let's just label them A, B. I have no idea where these are, so I'm just putting them random places. And then the distances in between them, this distance would be B minus A. That distance is C minus B. That distance is D minus C. And that distance is E minus D. Correct? So then they're saying that we have a lot of distances here. 5 points, not necessarily different, are selected on a number line so that the distance between any two of these points is at the most 1. After I calculate the distance between each pair of points, we got 10 distances. Okay, I think I got it. 10 distances. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the first distance is A to B, right? And that's B minus A. Okay, I got it. And then A to C. A to C would be C minus A, and so on. A to D, D minus A to E, E minus A, and then so on. You guys get the point. B to A, I think that is covered in this. I think they're not going to double count. It's a good thing that they said it's 10. That gives me an idea. So B to C is C minus B, and then what are the other ones? BD, that's D minus B. BE is E minus B, and then CD is D minus C. CE is E minus C, and then finally the last one, DE, which is E minus D. Okay, got it. So then these 10 distances, these guys, are all added up because they want the sum. And when you do that sum, I'll let you add it all up. It is going to be 4E plus 2D minus 2B plus 4A. Okay? When you add up all the letters. Now they want the greatest. So if you want the greatest possible, you're going to have to maximize this guy and minimize this guy. Minimize. Okay? So let's see how are we going to do that? How are we going to maximize and minimize? Well, if this is a very important point, not necessarily different, so they could be the same. So if they're the same and I want to minimize this, why don't I just let B equal to 0 and A equal to 0? If I do that, this whole term becomes 0. And if I want to maximize this guy, how can I do that? By staying within the parameters of the question. Distance between any 2 points is at most 1. So the maximum I can make E is 1 because A is 0. Got it? I hope that made sense. Let me see if... Yeah. And very similarly, that's the most I can make for C and D. So that would basically mean that it's kind of like this. This is A and B. They're at 0. And then C, D, and E are at 1. And this scenario would fulfill the criteria of the original question. So I'll just do that. C is 1, D is 1, and E is 1. If that's the case, then this term basically becomes 6. Right? Because E is 1 and D is 1. So that becomes 6 minus 0, which is 6. And therefore 6 is the answer to this question.